45. So then it is 50, 45. So this is the typical geometry we have thought of. Suppose this is a clay material. Clay material C is in the range of 120 kilopascal and phi is in the range of 23 degree. And unit weight, the clay is in the range of 1.75 kilonewton per meter cube. 1+7 gram per cc. Minus 3. 1750 kilonewton per meter cube. This is our unit weight, we will assume, and our material constitutive criteria we will assume more coulomb, MC category. So to do that, we have to start with add geometry. We have to start with add geometry. That is boundary, add external boundary. There is in the bottom right end of the computer. You will see data input. So we will give 0 space 0. So one point will come. Then we will give 0 space 10. 0, 0, 1 point, 0, 10, another point, then 10, 10, 10, 20. What is the height? 10, 20. 10, 20. No. There is a wrong. We have to undo it. Okay, yes, 0, 20, 10, 20, yes, add boundary. So 0, 0, then 0, 20, then 10, 20, then 30, 45, then 50, 45, then 50, 0, then 0, 0. So our closed geometry being built. Our closed geometry is built. In the last you have to give the 0, 0. In the last you have to give the 0, 0. In the last you have to give the 0, 0 to close the boundary. You have to undo it. Again you start boundary and let's start. Yes, go on. There is some mistake. You have to start with easy. Okay. So, no, from right to left. Right to left. You see the condition? 0, 0, 20, 10, 20, 30, 45. Huh? Yeah. Right to left.
So right to left, हम left to right कर देते हैं.
So geometry is done. Now what's the problem? Points you saw. Yes, this is right. So what about you?
Give me what?
0, 10. 0, 20. there is some mistake, I think. There is some mistake. You go. 0. There is 10 you have done. It is 0, 20. So you again edit. You can edit. You can edit. But it is better to start again. Coordinate. Assign the properties. Assign the properties. Our material is only one. So okay, we have selected the material one already selected. Then we have to give the material properties of the material one. So our material is clay. We have changed the name clay. Color is same, 20 kilonewton per meter cube. Okay, there is a mistake. 17.50. 17.5. There is one mistake. 17.5. Cohesion is 120. Friction angle is 23. And we are not assuming the water condition, groundwater condition. So we will select that. So if you go with your cursor, it will show the properties. Unit weight, strength, type, more coulomb, then cohesion 120 kilopascal, and unit weight is 17.5 kilonewton per meter cube, and the friction angle is 23 degree. Now we have to assign for a limit equilibrium method the circle surface. In the surface tab, you have to assign the surface auto grid. For the initial solution, we select auto grid. In the auto grid, 20 by 20 means 400 points will be generated. From 400 points, the computer will try to simulate the least factor of safety, generating and increasing and decreasing the radius of that slip circle from 400 number of points. So okay, we will select that. Then our work is more or less done for the solution. Then we have to save the solution, save as. Now we are giving as a solution GIAN on GIAN problem 1 test 1. Any format you can give. We have given GIAN program test 1 starting with. So we save it. Then we are ready to go for interpretation, that is for a solution. Then there is a tab to compute, Control T or compute. it is solution mean calculated. So there is another tab to interpret. There is one contour type of the tab is available, or just below the properties tab there is one option to interpret the result. This is our slip circle coming list factor of safety as 2.317. Any have you saved it? Okay. Then our calculation to be started with this interpreter. Compute control T. Up to date already have computed. So then go for interpretation. Go for interpretation. Computation is done. Is done. No computation was done. Then select surface. Auto grid. Yes. Okay, 20 by 20, 30 by 30, whatever you like. Now it is ready to compute. Now compute. Control T. Yes, you have to define properties. Right. Yes, right. 17.5. Test is done. Now it is practice. Practice 1 will be, first coordinate would be, suppose we will start from minus 0 minus 10. Second point is 0 minus 10, 0, 0. Then it is 25, 0. Then you start with 40, 10, then 5, 45, 50, then 6, 60, 50, then 7, 60, 0, then 8, 60, minus 10, then 0, 60, 0, yes. Then you have to again return to the initial position. No, only 8 point. Finally, you will get the 9 point though. 9 and 8 is the same. 9 and 1 is the same. So 0 minus 10, 0, 0, 25, 0, 40, 10, 45, 15, 60, 15, 60, 0, 60 minus 10. The purpose to give you this problem is, I assume that there is no one single plane of slope surface, there is two plane of slope surface, so that what kind of slip surface will be generated by limit equilibrium method. This is contour of the factor of safety. So this is the least factor of safety that is shown.
charges and the materials.
So you can assume the same material property as the first one, and I want to see whether you are able to do that. Then we will go for a solution using groundwater condition.
ആദ്യം 0 120 23 degree. Water surface
No, there is one mistake. There is one mistake. No, there is mistake. There is some mistake. There is some mistake. Probably right. I will check. So coordinate. Now I will check 0 minus 10, 0, 0, 25, 0, 20, 40, 10, yes, 45, 15, 60, 15, 60, 0, 60 minus 10. Very good. This group have done very good. Yes, one purpose was to give two. You will assume material two condition. Then you assume sandstone. At the bottom, C is basically 250 kPa. Phi is 27 degree and E is 21 kilonewton per meter cube. This sandstone would be the bottom portion of the slope would be at the foundation of sandstone. So to start with you have to assign two type of material properties. Not only that, at the bottom you have to lay another boundary. In the bottom you have to lay another boundary. That is, add boundary or expand or change boundary. This is done. The boundaries, you have to add boundaries. Add boundaries. Yes, done. Then we can select define material 2. To assign two type of material, you have to go to the boundary and you have to add a material boundary between the point of 25 0 and the 60 0. So you have to extend another new line between 25 0 and 60 0, so that another new material boundary will be created. So define material. The material 2 would be of sandstone, SS, and the material 1 is clay, CL. CL. So you assign the CL properties as 17.5, then cohesion 120, and phi is 23. Okay, then for the sandstone the same, it is 21.2. 21.2. Then the cohesion is 250, and the phi is 27. It is selected. Now assign the properties. This is the clay, it is done. This bottom is the sandstone. So we have selected two type of material. Now after selecting two type of material, you can select. No, there is some mistake. There is some mistake in the drawing. This drawing is correct. This drawing is correct. This drawing is correct. No, you have done two material boundary. This is correct. This is correct. For all of you, is it coming for all of you? 4.20. What about real?
श्लोक डब्ल्यू भी है क्या?
4.20.
श्लोक डब्ल्यू है ना? सर्वर है वहाँ पे जाता हूँ।
Follow some criteria. One is a certificate.
Then you have to keep the surface. Then complete.
Complete. Next.
Yes. So the steps is, if I summary, in our limit equilibrium method, the steps are: first you have to develop the geometry, then whether there is more than one layer of material or not, then you have to add the material boundary. Suppose in a soil slope, it is a possibility that you are going to face at least a few soil layers. Maybe at the top black cotton soil, then at the normal country soil, alluvial soil, then sandstone, shale you will going to face. So to give that material into the model, you need to assign material boundary. Here we are not considering the contact between two material as the interface, because it is only limit equilibrium method. So we can assign different type of material boundary on the geometry. That step been shown. Now after that we have to select which type of material I am using. The software can recognize, okay, if the material is behaving according to the Mohr Coulomb law, then the material type is Mohr Coulomb. Yes, there are some other models also, CAM clay, particularly applicable to soil, CAM clay model, there are other few also. So based on that, material parameter is also vary. So generally accepted norm means we do practice here, that is Mohr Coulomb we assume, and we know in the laboratory test also. If we test the material, in the last class we have done the test in the laboratory, triaxial, uniaxial as well as tensile and point load. If we test the material in direct shear, we can get a curve. So the curve will indicate whether the material behavior is matching with the Mohr Coulomb behavior or not, Mohr Coulomb circle it is fitting or not. If it is fitting, then assuming Mohr Coulomb criteria will suffice to our purpose. The next is that material type you have to give the material data. There is also window, then they will give it, then you will assign that material against the material boundary. Up to this is sandstone, up to this is clay, up to this country alluvial soil, up to this something else, shale, like that. After that you have to assume to solve a limit equilibrium method to assign grid. Means from which place actually the software will search and extend the slip circle and will find the least factor of safety. That is why we are assigning the auto surface, auto grid here in the mode, because if you have to assign by manually, you need to have some experience from which place it will select. But software has some general understanding. Okay, up to this I will select the grid. Up to 2020 means from 400 points, the software will calculate with different radius within the material boundary and to touch from bottom to top, and they will find the least factor of safety circle, and at the end the software will interpret you the least factor of safety circle with a contour plot. So this is the objective of giving you a problem and solve it in the slide, and many industrial problems, simple slope stability problem, can be solved using this software very easily. The software is very handy, very useful and very easy to understand fast initially even if you don't know. So that is the easy portion. Then we will go to assign groundwater table artificially. Though it is very difficult to assign in the field, it is very difficult to measure in the field the groundwater condition. That is why generally in a sophisticated numerical modeling we assume ferritic surface. It is better to be in the safe zone, don't make mistake. So geologist says, geotechnical engineer says that to pinpoint, to measure exactly in the field the groundwater table is very difficult, because groundwater table have a property at the top of the groundwater table, pore water pressure is 0. So where that pore water pressure is exactly 0 you don't know. So the perception is better to assume a ferritic surface type of line. That will also give you some equal amount of result, not equal. So generally we assume ferritic surface. Then we solve using the this slide software. Then now with the same problem, we will assign groundwater table from so the coordinate. So we will assign a table from 250 to 6015. We will assign a table from 250 to 6015. How to do that? Go to the groundwater, not go to the groundwater. Oh, it is interpreter. Okay. Go to the original calculator slide. Go to the boundary, add water table. So we will start from 250 to 6015. Done. And the material through which the groundwater table will pass both CL and sandstone. And in the project setting, means analysis. In the project setting, we have to go and select that yes, we will assume the water surface and okay, it is done already. Is it required transient? Normal water surface we will assume. No transient, no nothing else. So we will see how water table going to influence you initially. Water table influence means when I am adding water table, water have a G of means unit weight of 9.81. So that I have already given in the software. It is actually recognized that, and software is automatically taking care of that. In the same, we will save it is another file, test 2a. Now we will test again how it will vary. No problem. Wherever I select, it is okay. So, after calculation, it will come reducing to 3.8. After assuming the water table, the factor of safety reduced by 4.2 minus 3.8 means 0.4 divided by 10% reduce. 10% reduce the factor of safety. Now to increase the complexity in the geometry, we can assume another point, another material boundary. This 60-50, na? 45-15. Okay. Assume another point. 60-10. Assume another point 60-10, and the material is suppose coal. Material is suppose coal. It is it is 16, not 16. What is the average density of coal? What is the average density? Average coal meter cube. C is 80 kilopascal and phi is 21 degree. So at the top layer you will assume coal and you solve it using the groundwater table. With the same problem you edit it and show me the factor of safety you calculate. So you have to add another new point in the existing problem, and you have to add one new material boundary joining the points 40, 10 and the 60, 10. You have to add one point. Add point means boundaries add vertices. Yes, 60, 10. Done. Then we can extend our add material boundary between this point and this point. Then right click, done. Now we will go to the properties of the material, define properties, then assume it is coal. Write down coal. Coal. Then it is 14. 14. Then it is cohesion is 80. And this is 21. Then it is done. Then going to the assign properties. Now 3 material layer is constructed. At the top it is coal, at the middle it is clay, at the bottom it is sandstone. Now you solve it. You undo everything, then you solve yourself. Okay? Your material boundary is written. You undo it, means save and then again start from, so that you can also practice. So now 3 material boundary and 1 and water table between 40, 10, not 40, 10, 20, 0 and 60, 15. You did. 2.7. 0.024. Okay. Oh, maybe you have not assigned again the water table to all the material boundaries. We check. We check. 1 minute. Go to the problem. Assign properties. Assign water surface. Water surface. Assign water surface. Is it computer? Is it computer? So you solve it. 4.02. Why it is so? Why is there the difference coming?
They selected coal in between the materials, between the two materials. They have selected coal at the top.
At the coal at the top, yes.
They have selected in between. The
No,
black
no.
color is the coal.
Black, top is coal. Top is coal. Why it is difference is coming? surface again so that and rectify the problems. Then again see how solution is coming. Goal at the top. Then add water table. Add water table. Add. No, top. 60. No, 60 is 60 10. It is a material boundary. The old water table boundary you have to assume. And for select all material boundary. Then you save it. Save as. Now you assign surface.
60 minus 10.
And so.
64.
4.02 is the result.
What is the lowest real root, sir? 60. 60. 60. Now last one is 0.
बोला है क्या? She's done. I think all of you have done. Now we will switch to another software numerical modeling tool, that is FLAG, and that would be helpful for you also to estimate the factor of safety. Yes, okay, very good. Okay. Okay, next numerical, now we are switching to flat. The same material will be there, same boundary, same material condition boundary will be there. We will move to flat now. So where should I sit? A new place. Now I should sit at the middle. Give me a chair. The flag is in the flag. We will select SI as a unit. Include water table. Yes, we will click the include water table, and no structural element. Okay. Then title is GIAN test 1. GIAN test 1. No. Title should be slope stability. And save as GIAN test 1. Okay, now we have to build the model.
New, sir. New.
Okay, in the new. So our model is basically the simple one. Our model is basically the simple one. So we will select the simple, and in the select you can assume there is a tab to give you the coordinate, not directly, but there is some rule. What is our rise? Rise was 20 to 45 means 25. 25 is our rise. In the same, you see the geometry. What was the rise? Means height of the slope. It is 25. 20 to 45. Slope angle. What is the slope angle? Can you calculate? Anyone can calculate? Or I will go to the run. Run means this portion. Run is 10 to 30 means 20. Run is 20. You cannot. You also avoid the giving the slope angle. You can go for run. What is the depth? Depth is 20 30. No, 0 10. Oh no, depth is 20. Yes. Depth is 20. Then the left is 0 10. Then the right is what? Right is the slope surface length. It was 20. It is 20. And the lower axis, lower left means the starting point. Starting point is our 0 0. Okay, apply. Okay. So the same geometry been built with the flag. Same geometry is built using flag. It is okay. It is okay. Now it's okay. Now go to the next. Build. Build means I want to give material. Which kind of material? Create. We will create material. It is a class is soil. Soil, then it is clay. More coulomb. The density is in kg per meter cube. Kg per meter cube means you have to multiply by 1000. Not 1000. Kg per meter cube means what is the kg per meter cube for water? 1000 kg per meter cube, the water density. So it is 1750 initially for the clay. Porosity you assume 0.1. Cohesion initially we have given 120 kilopascal, not pascal, then it is 1000. Huh? Model, material model. So 120 kilopascal means into 1000 means 12,000, 1,20,000. sufficient?
No.
Tension 0. Angle of friction angle is 23. Dilation 0. It's done. Okay. Then we have to select this. We have selected the material. We have selected the material. It's okay. Then we go. We have to generate the grid. Yes, we have to generate. We have to give then we have to create mesh. Finely mesh or coarsely graded mesh. Just for assumption, we assume fine grid mesh. Okay? Mesh means for a numerical methods, we have to generate mesh. Then solve FOS. Using friction circle, friction angle and coefficient, they will solve. Now they will give you a limit, and after that they will give you the output. Okay? Steps you noted. Steps you noted one after another, then you solve it again yourself. Okay? Are you ready to do that? Yes? Find this incident, then if you don't so are you going ahead? Going ahead, yes. You solve all three problems using these methods again. You solve all three problems again. What is the problem? We'll go here, then go to the material, then select. So, the whole one. This number is the problem. Then we go for solution. We go create the solution. Leave the mountain. We just create So note the steps and solve all the three problems in this way and see what is the problem coming and what are the differences coming with black and black in the slide. Okay? Yes, very good. Ready?
डायमेंशन सेम था क्या था?
Yeah. Add move. Suppose you want to add one. Suppose add. Add हो गया.
हम लोगों ने पहले स्टार्ट किया ना, सर बता रहे थे तो उसके हिसाब से एंट्री कर रहे थे. हम लोग स्टार्टिंग हो गए हैं.
Starting is done. Go to the material.
हंड्रेड स्टेज कर लेगा. 100 स्टेज तक.
Okay. So to add different type of material, there is add material boundary type command is also available in the model. Go there. And you add all the material so that it will be safe. So you can import later on. See material.
130 question and 23. Next, come to call. 14 kilogram.
The bracket is showing the constant factor. You just read the fine. You have selected the clay material. Keep for some 30.1. You may have selected fine grade during course.
ഫുൾ സാൻഡ്സ്റ്റോൺ ഈ ഫസ്റ്റ് അല്ല അതൊക്കെ ഫസ്റ്റ് പ്രോബ്ലം ആയിരുന്നു പ്രോബ്ലം അങ്ങനെയല്ല ഫുള്ള് ക്ലിയർ
This was full kilo.
first problem is this
Solve FOS.
അച്ഛാ നിങ്ങൾ രണ്ട് ഇതായിട്ടാണ് വെച്ചിരിക്കുന്നത് അത് ക്ലെയിം
അത് 212 ഓക്കെ പൊറോസിറ്റി പോയിന്റ് വേണം സാംസോണിന്റെ പൊറോസിറ്റി
In that sense, the GIAN is different. It is a limited kilometer. So generally for a basic solution, people goes for a limited kilometer, that is slight. But for a complex problem where material is very soil, it can take load, mass load, there is large amount of deformation. When you considering the deformation, then you have to go for numerical solution. Not only underground in open cast also, where there is a possibility of large amount of deformation. Because light will not give the amount of deformation. It will only give you the factor of safety. So the advantage in the numerical method that you can also calculate the stress. Because suppose for an engineer who is in charge of the site, he needs to know what is the stress is developing, what is the strain is developing, what is the amount of deformation going to be developed on the slope crest or slope 2. Suppose some amount of deformation you know 1 meter. So you have to keep arrangement that 1 meter deformation is coming. So you have to arrest it. You have to take the simulation measure. So in that respect, this type of modeling, numerical modeling will help you to take a prior step to make a safety arrangement for the manpower, machinery and outside. So depending on the requirement, so about this factor sheet is coming is 0.63. So it is true that slide is basically giving higher factor of safety. So it is not safe. So for this material, our software is telling only 0.63. Though the way it solve the factor of safety, the way limit equivalent solve the factor of safety is different. But they should match up to certain limit. So we have to check what problem is there. But it is showing that it is less amount of the factor of safety is less. So we have to take care of it. Not only that, the advantage is now see the advantage. Plot.
if you go to the plot, now you see the beautiful slip circle or the possible shear band going to develop along this plane. So there is a possibility that the material is going to fail in this direction. So the flag software will tell you not only the amount, also the direction in which direction material going to fail. So this is the advantage. Not only that, we can also, using some command mode, the same software, we can also get the displacement rate. So in the plot, go to the items. See the items. Suppose I want to know where there is already material is failed. So I want to know plasticity indicator. Suppose vector applied condition I remove. Now I have to see. See, already in this zone, material is already failed. Means the material have a strength. The stress developed at that point is beyond the strength. So that is why material is already yielded, not failed, yielded. It is a ductile material, I assume, more Coulomb character. So it is already yielded. So large amount of deformation going to occur. So with the command mode also we can also plot the see the shear band developing. See the shear band developing. Along this also there is a plasticity develop, yielding. See the star. At this point yielding is already done. Yielding is already done. So along this shear band, that is why it is better to estimate for a complex problem to use this kind of software. Okay? The advantage is this. Okay? Now, learning this, you also extend your knowledge to this row. Okay? So that they can also learn. Till ask question.
Sir, because of
Sir,
fine material, that's why it will give a less
yes, not only that, C is low. It is in any based method. So calculation type is completely different.
Sir, it is not like some other.
Yes, now go to build model. See, here we can add layer. There is another layer we have thought of earlier. So add layer. Edit this add. Edit numerically. Our yes should it is in the 20. It will perfectly fit. It is done. Then in the material, you have already selected two type of material. It is sand. We want to select the sand. This is clay. This is clay. Then done. It is okay. Then again go to the solution and find bridge. Then solve. Okay. Now you can transfer your knowledge to the next group.
Completely clear, right? All is explained in the previous video.
Yes.
We want to less hypersensitive regions. What is the possibility to do less hypersensitive regions?
No two. It is showing shear band. Means along that line, a shear movement is going to occur, and you have to take care of this zone.
Sir, it is in open platform.
Huh?
It is transferred this is in open platform. How can we transfer now the road is active? Supports
Any structure have a geometry. So you have to first build the geometry, and you know where the material is, which type of material is, just assign that, and that's all. It is not a problem specific. Geometry, any type of geometry can be built, any type of geometry can be meshed, except it will not predict failure. It cannot predict the fracture. It cannot predict the fracture. So for that, you have to go for a different kind of software, discrete element based method. So normal, whether there is a large amount of deformation, dam, embankment, open pit slope, Up till some already crack develop, up till that, this model is very firm. That is not in the syllabus. That is only for our research purpose. That is real. We have already. I am also don't know. I will learn and I will teach. Because it is coming, game on. We have different software that is discrete element. That is discrete element. Flat, UDEC, not UDEC and flips.
There is one other method also, discrete fracture method.
Yes. You can use this method in the PFC also.
Sir, what is the difference between these methods?
Discrete fracture method is there is a force on it, and then what is the water pressure, how the tells you discrete fracture method.
There are discrete fracture method was the earlier development. Now the discrete element method is developed. So applying that algorithm in the discrete element, you can pretty well couple all these approaches. Okay.
There was a small university also. There was a small university
So are you fine with the modeling? You need to solve the three problems I have given. Oh, one important thing in the software, we have an advantage to plot the deformation, and very important thing is plasticity indicator. Means in numerical models we know, in the test also we know, if the applied load is surface the material strength, then the material will yield. Material will deform, permanent deformation will occur. So that is called material is yielded. Means material is already failed. So this software have the facility to tell you at which point actually, in which zone material is yielded. So there is a plot. After solution is done, there is a busy. Which computer has already done the solution? Yes. And go to the plot section, items. In the items you have plasticity indicators, shear strain band, velocity. You just remove this. Applied condition, remove this. Okay. See, in these zones already, see here it is written in the star mark at yield or yield in shear. So it is already yielded. Means these zones are very unsafe zones. So the analysis in this method are deep. Means deep amount of means more amount of information you are going to get about the stability condition, deformation. If we apply some comment, we can also get the X amount of deformation in this direction. What is the amount of vertical subsidence, vertical amount of depression is going to occur with vertical displacement contour, X displacement contour. We can get the plasticity indicator, which point the material is already yielded. So these are the advantages. That is why for a complex case and for the cases where there is a large amount of deformation is expected, those cases we use this kind of numerical method. Now you solve it. This is the plastic. It is indicated in the shear strain plot. Shear strain, STRAIN, strain means amount of strain is going to means amount of deformation. So what is the highest deformation? this is the highest deformation, 7. Please repeat. You have to see the value and then you have to check. It is actually in a broad category. In a broad category, it indicates there is a shear bands. Bands means it is not only one line, because actually it is not line. Failure is not only along line. Some of the material is failed, some of the material is effective. So it is showing their job. That
How did they calculate? Because we were
so that is on the preview of the numerical method. So this calculation is based on iteratively solving the differential equations using the method of finite difference method. Using the method of finite difference method, FDM. This is a mathematical algorithm. That algorithm is in the back, it is running in the software. So they are updating the strain regular interval, updating the every second, and finally this is taking the result. This is coordinated very real to the field condition, very real. Get quickly, because after a few minutes you have to go to the ETC and attend the class. Get brass up and solve all 3 problems I have already assigned to you. Okay. Hey, those who are facing to add the boundary layer, come here and see. Come here in this computer. Those who are facing to add the boundary, material boundary, extra material boundary. Oh no, this is not. Layers. It is true, it is no problem.
sloping.
Delete. This is to be deleted. Not deleted. This is to be deleted. It is done, okay. So it is done, okay. So have you not assigned any material here?
No.
Have you not assigned any point here?
Yes. The point is
Yeah,
No. Most probably you have not assigned points.
So second case we are mentioning.
Delete it. Go to the new. Our model is basically general.
Oh, we provide bench.
See, in the bench, okay. Add numerical points. Here the option is add numerical points. Edit. Okay. Add numerical points. Go on that giving the coordinate system. What was the second coordinate system? 0, 0, 0. Then 0, okay. Second was 0 minus 10. Sorry. 0 minus 10.
0, 0.
Then 0, 0. Then
25, 0.
25, 0.
40, 0.
Huh?
40, 0.
40, 0.
40, 10.
40, 10. I am relying on you.
45, 0.
45?
15.
15. Then 60, 15. 60, 0.
60 minus 10.
Huh?
60 minus 10.
60 zeros. 16 zeros.
60 0.
How it is coming 60, 0?
45, 15, 60, 15,
60 0. After that, 60 minus 10.
60 zeros.
Okay.
60 minus 10.
Minus 10, yes. Then
0 minus.
Oh, 0 minus.
0 minus 10.
It's beginning.
Oh no, initial point is not required. Another is, in between I have added 60, 0. 60, 10.
60 minus 10.
60, 10. Okay. There is some problem.
We are initial distance of
60-10. Where it is coming 60-10?
60 minus 10.
60-10.
60-10
Here it will come.
60-10.
Yes. It is done. Okay, then you have to add the material boundary. Yes, I was wrong. No undo. It was necessary to build the layers. Okay, we can add layer. It is already added layer. Edit numerically. It should be 10, not 0 10. It should be 60, 45 10, 40 10. 40 10, then it is 60 10. Edit 0 0 0 0. Okay, it is taking care of that.
0 minus 10 and 60 minus.
Actually, we generally use the command mode and we build the material boundaries in different way. That is why it is not coming.
We used to benzone.
Bench 2. What was the rise 1? Rise 1 initial. Can you build? Can you have drawn that picture? Rise 1 was most probably 10. Rise 1 was most probably 10. And rise 2 was
5.
5. Yes, rise 2 was 5. And the run is 25 to 40 means 15. 15. And for the run 2,
Run 2 is 5.
rise, slope. Run is
Run to 5.
5 only.
Yes.
Huh?
40 to 45.
40 to 45. Okay.
For 5. Run 5.
Okay. Huh?
Run 2 is 5.
Only 5. Okay. Depth.
Depth 10.
10. 10. And left.
Left is
25.
25.
Yes.
Right is 15.
Middle is 0.
0. Right is 15.
Right is
15.
15. And the lower is
0 minus 10.
0 minus 10. Okay. Okay. Then again go to the build, layer, add, edit, 0 0.
It's not 0, 10.
Coming so?
Change the point of the
45, 0. 0. What is the third coordinate?
60, 0.
No, this coordinate.
That coordinate 40, 10.
45.
40, 10.
40, 10. Okay. The last is 60, 10. Okay. Ah. That was the mistake because for many years I have not practiced this. Okay. So it is done. Now you go to the material you have already selected. This is coal, this is sandstone, this is clay. Done. It's fine. Go to solve and finally grid it. Medium, coarse. Okay, we can also select okay. There is another needs to be taken care of. What layers? Add another. And we have to edit it from the initial position. 0, 0. What is this coordinate?
25, 0.
0. Then this is
40, 40, 10. 40, 10.
then what is this?
45, 15.
And the last
60, 50.
my four layers do not have material. Why it is coming so?
The memories of stone you have mentioned the porosity, just the default values are going for should we change? Will that affect?
So, curves కూడా డిఫరెంట్ అక్కడ మధ్యలో ఒక డివైడర్ అది we can differentiate between coal and clay, right? We have the ordinate idea. We have idea about the ordinate.
We used to bend to right.
I will check and I will tell you. So, dear student, let's move to the EDC again. We'll start the